Quick video today, I hope. The cousin of a friend of an acquaintance of a complete stranger, who evidently doesn't care to have a real machinist do this right, asked if I could machine a PTO adapter. Specifically, just the male PTO features, which fundamentally is a standardized spline. In this case, a standard 1-inch 6-spline fitting with parallel sides. PTO stands for power takeoff. You may have seen these things sticking out the sides of farm and garden equipment. They're like electrical outlets, but for mechanical power. You'd plug other stuff you want to power onto them, like log splitters or mowing attachments, that sort of thing. I've never cut one of these before. And after learning that it's some sort of hack backyard project, and more importantly, no one can get hurt here except their wallet, I said, what the hey? First thing I had to do was find information on a 1-inch 6-spline PTO shaft. Of course, I turned to the machinery's handbook. Fortunately, this thing has all the information I'll need to pull this off. And since I'm only responsible for the actual spline, we'll knock this back down and take it over to the mill. You likely saw this coming, but I'm set up in the dividing head. I didn't make this part. This is as received. The owner, from what I understand, has a lathe and a welder. And on close inspection, probably also an angle grinder. That, or more than likely, they tried to test fit this on a bearing or whatever this attaches to. Best I could do is get this thing centered to within about 1.5 thou. That's total run out. After 20 minutes, I've given up and calling that close enough. According to the good book, if I do the rest of this right, I should still be in tolerance. That and their finished OD, where the spline goes, is a bit undersized. Let's pontificate a moment, shall we? Without being a complete and utter about it, of course. Here's what I think happened. They held onto this part here, same place I'm grabbing it with my dividing head. Probably obvious enough, right? And turned down the features that they needed. The 1.5 thou I'm seeing now is from their 3-jaw chuck. I mean, maybe a little is coming from this 3-jaw too, but I bet most of that was just their chuck and working off the OD of raw stock, which is fine. They also took a skim cut here on the large diameter, and if we could cut the back of this part off, we could grab that and be in a better situation, concentrically speaking. But they either went to town on this and took their measurements hot, or they used an older, worn PTO to figure out what the dimension should be. In either case, our major diameter is now undersized. Now, what does that all boil down to? Well, I'm not going to volunteer for the extra work to get this thing dead nuts. Or in metric, spot on. I agreed to do this for a couple of reasons, and on the premise that I might not be able to pull it off. First, like I said, I've never done anything like this before. I've never cut a PTO spline. And second, I don't have the right cutter to do it. All I have is a regular milling cutter, and I'm curious to know if I could approximate the PTO spline using one of these. These splines have a minor diameter. That means in between the splines it's round, and technically I would need a form cutter of the right size to do this. Something that in one pass would leave a finished spline profile. This cutter is going to leave that minor diameter a bit faceted, I guess depending how much I approximate it. Hopefully that'll make more sense as I work through this, if this works at all. You might be wondering why I'm not using just a regular end mill for this, and that's good. I briefly considered the same thing. Using a regular end mill like this to cut the splines would result in an abrupt end to that feature. Like where it stopped, it would look like a key seat in the shaft, just like a sharp inside 90-degree corner. I couldn't find anything specifically in the book. I didn't dig too hard, but PTO shafts usually have that cut feature taper out. So if I come in here with a milling cutter and do the same groove, that cut will feather out. It won't stop abruptly. I don't know if that's necessary, if it's done to reduce stress concentrations, or if it's just a result of the manufacturing process. In either case, I'd like to mimic that lead out on the spline cut. So I'm going to use one of these. Somehow, all of a sudden, it's the next day. Time flies when you're having fun. Got the milling cutter mounted on my 80 RPM 0.5 inch per minute mandrel, 12 to 13 millimeters per minute. A bit perhaps on the conservative side, but this looks to me like a reground cutter. I've never used it. It feels sharp, but I don't know how well it's going to do. I'm going to start off slow and see how it works. I've snuck in behind here to pick up the height of the workpiece, the top of the workpiece. I'm going to use that to set the height of the cutter. And this is what I end up with after 12 passes. I did 6 cuts on one side of the spline and then 6 on the other. It's left me with these little pyramids here. That's the faceting I was talking about earlier. I'm now going to come in, 6 more cuts and try to knock those out. We'll see how that looks and take it from there. And there it is. It's probably not going to end up on the cover of National Geographic, but according to the numbers, this thing should work. I did my best to get in there and deburr it with a couple of small files and a stone. I didn't do an exceptional job. You can see some scuff marks here and there. I'll probably hit this with a little bit of Scotch-Brite or a wire wheel or something just to make it look a little more uniform. But as is, there aren't any sharp corners, so no one should get their hands torn up on it. Lessons learned? Well, just like most things in machining, the first time, once, is always fun. But if you had any more than maybe one of these to do, I highly recommend you buy the correct cutter. All in all, it didn't take too long, but this could have been done in 6 passes and we would have ended up probably with a much better surface finish. A lot less guesswork. That's it. Thought I'd share. Thanks for watching.